Hello and welcome to another video. In this video we're going to be working on minimum difference between largest and smallest value in 3 moves. And so in this you're given an integer array nums, and in one move you can choose any element of nums and change it to any other value. Return the minimum difference between the largest and smallest value of nums after performing at most 3 moves. So in this first example, basically if the array is small enough, if the array is 4 moves or less, you can basically turn everything into the same. So if the length of the array is 4 or less, you can just take 3 moves and just turn every number into the same thing. And then your result will be 0. So if the length of the array is less than 4, it's just, or 4 less than or equal to 4, it's just always going to be 0. So here we have 3 more moves. And basically now we can change up to 3 numbers. So there's a few ways to do this, but one of the ways is just change everything into a 0 or a 1. Because 0 and 1 are the closest to each other. So you can just change everything into a 0 or a 1, and then you have a difference of 1. So like this would become 1, 1, 1. And second example, same thing. Or third example, because the length of our array is less than 4, or less than or equal to 4, we can just turn everything into the same number. So assuming we have an array, let's just have a sorted array of a bunch of numbers. Let's just have a few numbers. So like 0, 2, 8, 10, 12, 20, 30, 50, 100, and maybe like 101. So if you have 3 moves, like let's just keep it simple. If you have 1 move, what would you do? So we want to make sure that like this is minimized. So obviously you can recognize if I have 1 move and I change any one of these, then my result doesn't get any better because all I care about is the minimum and the maximum. So then I know I want to change either the minimum or the maximum. And then how do I decide that? Like what would I want to change it into? So I could just change the minimum or the maximum into one of the numbers that exists already, and that would either change the minimum or the maximum. So basically, we can either say we'll change this 0 into like a 2, for example, and then the new minimum will be 2, or we'll change this 101 to be 100. And so if we change the 0, then we'll have a 2 and a 101, which will give us a 103 difference. And if we change the 101 into 100, let's say, like this, then we'll have 100 and 0, which is a 100 difference. And so that's better, right? So actually, I think I might have said this wrong. So if I change the 0 to a 2, then we'll have 2 and 101, and the difference is actually 99. Yeah, I did say that wrong. And then if I change the 101 to 100, then the difference is 100. So the best thing to do would be to change the 0 to a 2. So you'd say like, okay, my change, and you can change it to whatever you want, but as long as there's numbers, you can change it into something. You can change it into 100 or whatever it is. So I could just do this. This is going to be the best with 1 move. But with multiple moves, it gets kind of tricky because you don't necessarily like you don't just always take the best one right away. Because let's say like I wanted to change a 0 to a 2, but I have 2 moves, right? So here, the best 1 move was change a 0 to a 2. But if we do that, then this becomes a 2. Now, our next move is we can either change, or I guess you wouldn't change a 0 to a 2. You'd change a 0 into like, let's say, some middle number, like 10 or something. Okay. Basically what it does is changing the number essentially just gets rid of it. Because you can always just change it into a duplicate of something else, as long as the array is big enough. So basically, you can think of, instead of changing a number, you can think of just like, I want to get rid of one of them. So the first one, it's better to get rid of this. But now what if we have 1 more move? Which is it better to get rid of now? So if we get rid of this 2, it's going to be better than getting rid of this, because right, if we get rid of this 2, the difference will be this, which is 93. And if we get rid of this guy, the difference will be 92 or 98. So the second best move, if you just do 1 move at a time, would be like this. But actually, if you start from the beginning, if you don't just take the greedy one, the best solution would be getting rid of these 2, right? Like I said, changing a number is essentially the same as getting rid of it, because you can always change it into a number that already exists. So the best thing to do would actually be get rid of these 2. But if I just chose the greedy every single time, pick the greedy one, I wouldn't get that. So the best is this, and then there's a difference of 50. And like I said, you're not really getting rid of these, but you can just change these numbers into like 10 or something. So you have to try out a bunch of combinations, and the combination you have to try out, assuming your array is big enough. If your array is 4 or less, like if your array is this, you can just change every number to be the same number, and then your difference is 0. But assuming your array is big enough, you need a sorted array. And then the first number, like I can make up to 3 changes. So basically I can either not get rid of this or get rid of this. I can not get rid of this or get rid of this. Not get rid of this or get rid of this. And then here I can't get rid of. So basically my first number is going to be one of these 4 for sure after I make these changes. And my last number, it depends on my first number. So for example, if my first number is this, so I'm saying let me just get rid of these 3 guys, I have no more changes to make. So my last number has to be here. But if I don't make any changes, then my last number can be up to 3 changes, right? So it can be this one, this one, this one, or this one. That would be 3 changes. So for the first guy, we have to check, like, what's the smallest result? It's going to be either this combination, this combination, this combination, or this combination. Then for the second guy, the combination, you can have one less combination, right? Because we're already making 1 change here, so we can only make 2 maximum here. So this would be none, 1, or 2. And then here, we can only make 1 more change or none. So this would be 1, this would be none, this would be 1. Or here, we can't make any. So we can just go through all those really quick and see like what's going to be the best. So assuming we make no changes, our starting result is 101. Assuming we make, let's say we make no changes here. Here, we can have a difference of 100. Here, we can have a difference of 50. Here, we can have a difference of 30. So given the first number wasn't changed, our best difference was 30. Now let's say our first number is changed once. That means this one can get changed up to twice. So obviously there's not going to be anything better. So like this is bigger, and this is bigger, and that's the most I could change is up to twice. And then we also check this way. So this is bigger, and that's 3 changes total. And then finally, if we make 3 changes here, we can't change anything at all. So our result here would be 30. So one thing to do is just split your array and do like a little nested for loop on the first number can go from indexes 0 to 3, and then the second number, you can make changes up to 3 total. So if like this is at 3, you can't make any. If this is at 1, you can make up to 2 changes and so on. So it would be like, whatever, 12 combinations or something. I mean, it would be a little bit less than that, but yeah, that's the idea. But you'd still have to sort. But the other main thing to recognize is I only actually need the first 4 numbers and the last 4 numbers, because those are the only combinations I'm checking. I don't care about the stuff in the middle, right? Like I only care about this because these are the only ones I can possibly have, and these. So if I only care about the first 4 and the last 4, instead of sorting, which would be n log n, we can just use a heap. And so to get the first 4 numbers, we can use a max heap. And to get the last 4 numbers, we can use a min heap. And we can just say we only need a min heap of 4 numbers. And then anytime that heap gets too big, we'll just pop stuff out. So let's quickly see what that's going to look like for the max and the min heap. So in the beginning, let's just try the, I guess, the max heap. Yeah, so let's just try the max heap. And the max heap is going to give us the smallest 4 numbers, and I'll show you why. So we're going to put in this number into the max heap, put in this number into the max heap, put in this number into the max heap. Yeah, sure. Let's just do it this way. Obviously, they won't be sorted to begin with, but whatever. So now we're going to put in, I guess let's like move the numbers around a little bit. So just to, yeah, so let's say it's something like this, because normally our array isn't going to be sorted. So let's say this is our starting array, and then we just do a max heap and see why we'd get what we want. And then let's make a copy of this just in case. Okay, there we go. So the max heap. So we're going to put in 1 number, then we're going to put in a second number, then a third number, then a fourth number, then a fifth number. Now our max heap is greater than 4, so we're going to pop our biggest. Put in this guy, pop our biggest. Put in this guy, pop our biggest. Put in this guy, and that is the biggest. Put in this guy, that is the biggest. Put in this guy, that is the biggest. So here's our max heap. And then we can just pop numbers one at a time from our max heap. So like this will be the first number, second number, third number, fourth number. And so you see how this max heap turned into the smallest 4 numbers. 0 to 8, 10. Now we can do the same exact thing with a min heap. So we can just take all these in order. So let's take this, let's take this, let's take this, let's take this, let's take this. Now we pop the smallest guy. pop the smallest guy, pop the smallest guy, pop the smallest guy, and finally. And this gives us our biggest numbers, right? So 30, 50, 100, and 101. So essentially, you can just choose two heaps, and because they're only going to be length 4, that's going to be constant space and constant time. Because to pop and push from a heap of length 4 is constant. And then you can do that same thing just using these 4 and these 4. So basically, for this, you would iterate through all of these numbers, and then like, let's say the first one is this, then the second one could be any one of these, because there are no changes here, so you can have 0, 1, 2, or 3. If this is here, then you can only have 2 changes total, so 0, 1, 2. If this is here, then you can only have 1 change, so 0, 1, and here it would have to be none. And same thing, you're going to get to the result of this being the best, where you have no changes here and 3 changes here. So that's the solution we're going to code, and this is why I said in other videos, if you need to keep track of like the smallest 2 or 3 numbers, even if it's not a lot, a heap is easier than a bunch of if statements, because a bunch of if statements is going to get really messy really quickly. Like if it's bigger than the smallest, but smaller than the second biggest or whatever, it's all messy. Just use a heap, and that's basically constant space. So that's what we are going to code. So we're going to have a min heap and a max heap, and like I said, the min heap is going to represent the biggest elements, because we're basically popping out the smallest element every time. So we're going to get the 4 biggest. And the max is popping out the biggest element every time, so we're going to have the 4 smallest. So let's do that first. So we can have priority queue, min heap. Okay, and so the default queue is a min heap, so you don't have to add anything extra. But for a max heap, all you need to do is just change the way the comparator works. So just like a sort in most languages, a normal sort, a min, like increasing sort is a minus b. So here we do the opposite, b minus a or negative a, or whatever. Like you can either this or you just make them both negative. So this would basically work. Okay. So now we're going to go through every number in the nums, add it to the heap, and then if our heap size is greater than 4, we're going to pop it out. Because like I said, you can only make 3 changes total. If you make 3 changes, you're on the 4th element. So you don't need any more than that ever. And max heap. Yeah, I think it's add. I think there's like also offer or something. I don't know which one does which. I think it's like the same thing. Okay. So anyway, so if the min heap size, I think, is greater than 4, we're going to pop. So I think this one I do know, and I think it's pull. Yeah, pull or remove. Don't remember which one does which once again, but yeah. And same thing for the max. Now I think this actually runs slower than a sort in practice on LeetCode, because using like heaps and all this stuff does have a lot of like overhead, but in, you know, at least in Big O, it'll be faster. Okay, so now we have our smallest 4 and our biggest 4, so we can say like smallest 4, the smallest nums, and that's going to be length 4. Oh, I forgot one more thing actually. So if our array length is 4 or less, we don't need to do any of this. We just know that we can just change every number to be the same. That way we're not running out of bounds, and we make sure our heaps have at least 4 elements. So if nums length less than or equal to 4, just return 0 because it's going to be 0. And we can store that. So int, actually, whatever, it's fine. I can just hard code stuff. Okay. So then we make the smallest num or biggest nums also going to be length 4, because if it was smaller, it would just return here. Then we're going to have a result, and we're going to try to minimize, so we'll just make it the max value. Max value. Then, oh yeah, I forgot. Before we do that, we need to actually take our heaps and put them into the arrays. So for int I equals 0, I is less than 4. All right, so if you think about it, so from our min heap, as we pop, like our min heap is going to be our biggest elements, but it's going to be left to right, right? Like our min heap, let's say, has these numbers. If these are our biggest elements, it's going to pop the 1, then the 2, then the 3, then the 4. So the index we're going to want to write into is biggest nums I equals min heap dot pop or pull. Yeah. Okay. Now our smallest nums is going to be a max heap. So if we have these numbers again, we're going to pop this guy first. So actually the first number we pop is that going to be the last index in our smallest nums. So we can do smallest nums for actually 3 minus I, right? Because it'll be indexes 1 through 3 is going to be here. So the first number we pop from the max heap will be the right, and then it'll go left. Okay. Now we just have a nested for loop checking all the locations. So the left side can be anywhere from 0 to less than 4, right? 0 to 3 changes. And the right side can be anywhere from 0 to 3 minus j is less than, so j is less than 4. You could say j less than or equal to, if you want 3, is less than the changes on the left. So if we have like 2 changes on the left, we can have 3 minus 2. And the reason we have 4 is because we have less than, so if you want this, then it'll be a 3. I guess we can do it that way, if that makes more sense. Okay. Hopefully that's more clear. So essentially on the left, you can have up to 3 changes. On the right, you can have up to 3 minus I changes. And now there's the index is going to be min. So on the first one, oh yeah. Oops. So on the first one, the index will be just I, right? Whatever, how many changes you have, that's the number you're on. So if you're on 0 changes, you're on the first number. If you have 1 change, you're on the second number, and so on. So this will be smallest. Actually, this is the number we want second. So we want positive result. So this will be this. Now in the bigger side, we're gonna go right to left, right? So for numbers like this, or let's say it's like this. So here, 0 changes is actually on the very right. So when j is 0, we should be on the last number. And then when j is 1, we should be on this number, and so on and so on. So this will be biggest nums, and it should be at index 3 to start out. And then as j gets bigger, it'll get subtracted. So I think it's this. So we take our biggest number at however many changes we have there, minus the smallest number. And yeah, basically, like I said, whatever that is, like 16, less than 16 combinations. Not very many. So this is basically constant time. The linear time one is going through the numbers and nums. And finally, return. So I do think this is like a pretty straightforward problem. Maybe using the heap approach is a little tricky, but not that tricky. And the main thing to figure out is you're only going to want to make changes on the ends. And then based on however many changes you make on one end is how many changes you can make on the other. And changing a number is basically the same thing as removing it, because you can always change it to a number that already exists. So then your minimum will be like, or your maximum will be the next number. So essentially you can reword it into, you can remove up to 3 numbers from the left or the right. What will be the new minimum, or what will be the new difference? All right. And yeah, I do think this is slower than the sort, even though in theory it's supposed to be faster, because there's a lot of overhead with like with min heap. So even though this is technically O of 1, there's still a lot of overhead. Okay, so for our time and space, this is going to be O of n, because like I said, our heap is length 4, so it's technically log n for heap push and heap pop, but log 4 is 1, and then space is O1. This might be wrong in these because I don't know if it will recognize it's, yeah, so it doesn't recognize it's a heap of length 4, but it is, so yeah. Okay, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.